Alright, hi guys. For this video, we're actually looking at this concept called variations. This is actually a lead up from the previous concept, which is on the genetic diagram. So now we're actually gonna dwell more into this particular category of concepts. So in this particular video, you'll learn about the differences between these two types of variation, and you should be able to give some examples of each of these variation. Before we get started, it's good to take note that variations, by its definition, right, refers to differences in terms of the traits between individuals of the same species. So, for instance, if you look at this diagram over here, right, I'm showing you these 6 different kind of packets of M&M, right? Although they are the same type of food, which is chocolates, right? But you can realize that they have very different appearances in terms of what they have, and some of them also have different kind of ingredients that's found within them. That's what we call variations. But for humans, right, in particular, when you look at variations, we can look at things like differences in terms of the eye color, or rather the color of the iris, differences in terms of the height, skin color, so on and so forth. So those are what we call variations. Okay, so it's good to take note that variations can be due to either your genes or your environment itself. So only genetic variation can be heritable, which means that it can be inherited from your parents. Variations due to environment are not inheritable. Let me give you an example, right? For instance, if you look around you, right, you might notice that some of us, right, we are born with a certain kind of feature. For instance, we are born to have darker skins, for example. So those are genetic traits that you have inherited from your parents, and those can be passed on to your children in the future. But we are saying that, okay, say, what if you go and pierce your ears today, or what if you go and do plastic surgery to make certain changes, certain variations to your features, right? Those kind of things that's affected by the environmental conditions cannot be passed down. Okay. Similarly, so for instance, if you are born to be very fair skinned, okay, but you keep going under the sun, as a result, you become very, very tanned. Okay. This doesn't mean that your child, when you give birth to your child, right, the child will be tan also, because that tanness that you achieve, right, is due to your exposure to all the UV lights and the sunlight, etc., over your entire duration of life. Right, so those are environmental changes. It's not what you are exactly born with. So only genetic variation that you have inherited from your parents can be passed on to your children. So let me give you an example. Over here, I have these two pictures. Okay, they're actually representing the same person. Okay, this is actually Michael Jackson before and after he had all his surgery, changes to his pigmentation in his skin, etc. So if he was born to have this kind of features, for instance, his nose shape, for instance, his eyes, his chin, or his cheekbone, so on and so forth, right? As well as his skin color itself, right? Or even the hair itself. If he was born with all these features, right? Even if you go for plastic surgery and everything, right? Looking like the one on the right side now, right? If he were to have offsprings, right? Have children, right? His children will not inherit these kind of features from him as well, because they will have inherited the original genetic variation that he got from his parents. So just take note that variations, although we are saying that we are comparing about the differences in terms of the traits, right? We'll be mindful to know that we are only looking at those that is like genetically inherited, not those that people obtain over their lifetime through the environmental changes. Okay, so right now, it's good to classify and let you know that there's actually two different kinds of variation. One is what I call the discontinuous variation. One is what I call the continuous variation. For discontinuous, right, usually you have specific phenotypes. So it's either you have A or you have B, or you have just like a few different types of phenotypes. But for continuous one, right, usually you have a range of phenotypes. So we'll take a look at some examples later on, and we see whether we can link it to whether is it looking at specific types of phenotypes, or are we looking at a range of them. So right now I'm going to show you certain variations, and I want you to just, at the back of your mind, look at the variation and think about should it belong to something that I call discontinuous or something that I call continuous. So the first example that I have over here, think about the variation of height. Because height is a characteristic, right? So, and of course we know that height can be different for different people. So is this a type of discontinuous variation or a type of continuous variation? Okay, think about it for a second. The second one, the ability to roll your tongue. Okay, I'm pretty sure some of us that are watching the video right now, you will know that you are born with the ability to roll your tongue. And some of us, unfortunately, you realize that no matter what you do, you can't seem to roll your tongue, right? So is this considered a discontinuous or a continuous variation? Are we looking at specific features or are you looking at a range of features? Thirdly, this is what we call a hitchhiker's thumb. Okay, a hitchhiker's thumb, right, is when you stick out your thumb, right, you can actually bend backwards at this portion. Okay, so I myself actually have a hitchhiker thumb as well. Okay, but for most people, you might have this regular thumb that appears in this manner. So the ability to have hitchhiker's thumb, do you think this is a distinct yes or no, or is there a range that can be in between, whether you have or you don't have? The fourth variation, eyelids. We know that there's different types of eyelids, basically single eyelid or double eyelid. So if you look at all the variations that I showed you just now, actually we can categorize them into two different types. Whatever that I show you on the right side now, okay, and compared to the one on the left side now, okay, the left side on the top one is trying to show you about weight, okay, the animation that is flashing. This is about height. Okay, basically I can classify that all those that's on the left side are what I call continuous variation. Why? Because they represent a particular trait that can occur over a range. For instance, your height can go from 1.2 to 1.21, 1.22, 1.23, so on and so forth until 1.81, 1.82, 1.83, all the way. There's a range for the height to occur. There's no such thing as you are under height A or you're under height B. There's no distinct differences. But if you look at the one on the right side over here, these have very distinct category. That's why we call them discontinuous variation. It's not a continuing trend. It's not a range. Okay, so it's very disjointed. Either you have or you don't have, or even if you have, there's only that few types. Okay, so something to take note of over here. This is the two types of variation. Okay, basically, this continuous variation is brought about by one or a few genes. Alright, and it can be categorized into distinct groups. This is the one that makes it special. Because for this continuous variation, right, we know that it's either you are type A, type B, type C, type D, type E, type F, etc. It's a very distinct one. There's no such thing as a range. But when you have continuous variation, you realize that because it's brought about by the additive effect of many genes, additive means a combined effect of many genes. That means all the genes actually they add on to one another, and you get the ultimate phenotype that you are observing. Okay? And as a result of continuous variation, you cannot be categorizing them into distinct groups. So let me give you an example. One very good example of this continuous variation is blood type. Okay? Because for blood type, right, you know very clear cut either you are type A, type B, type AB, type O, etc. That's only these four. Yeah, so there's no such thing as somewhere in between B and O, and somewhere in between B and AB, and somewhere in between A and O. There's no such thing as an in-between value that I can take. Right, so there's a discontinuous variation. Maybe another discontinuous variation that I can think of is say your eye color. Okay, or rather your iris color, the color of the iris. Okay, so you either have brown for Asians, mostly brown, or black. Of course, for the Caucasians, right, they might have blue iris, green iris, etc. But you won't see something that's like somehow in between. It's a very distinct trait itself. So we call those actually a discontinuous variation. In terms of continuous variation, one classic example is height. Because you realize that if you were to measure all the height of the people in the whole world, you end up getting a range. A range of people. So say this is 1 meter. Let's say this is 2 meter. You get a range of people that's somewhere around here, somewhere around here, somewhere around here, etc. And what happens is that you end up getting a curve, a range of traits that you can observe based on the height trait itself. You'll see a range from the shortest one all the way to the tallest one, and they won't be exactly giving you specific distinct groups. So this is one classic example of continuous variation. Okay, maybe another example to give you some idea. For this continuous variation, there can also be another type, which can be the fur color of animals. Let's say the fur color of a rabbit. Okay, it can either be white, black, or grey. Yeah, so this I can actually tell you that since there's distinct types of that particular trait, right, then this is actually what I call a discontinuous variation. Okay, so this is just some example to get you thinking about it. Now, how do we compare the two kinds of variation? Now, for this continuous variation, right, it's important to understand that they are dealing with a few clear-cut, okay, or what I call distinct phenotypes. That means I'm either looking at this kind or the other kinds. Okay? But for continuous variation, I'm looking at a range of phenotypes. So that's the first comparison between them. Secondly, this continuous variation, usually they are only controlled by one or a few genes. But whereas for continuous variation, right, it's controlled by many different genes and they have an additive effect. So you actually have to add up all their effects to show what exactly is the trait they are looking at. Yeah, so this is what I mentioned. Fourth, this continuous variation is usually not affected by environmental conditions. For instance, whether you can roll your tongue or not, whether you have single eyelid or not, it cannot be affected by environmental conditions, right? Whereas for continuous variation like your height, your weight, etc., especially your weight, it can be affected by environmental conditions based on your diet, based on your lifestyle. Okay? Your height as well can be affected by whether you are someone that consumes sufficient nutrients for yourself to grow during your puberty stage, right? So all these things can be affected. So those are called continuous variation. But this continuous variation, it hardly is ever affected by environmental conditions. Right, so some examples for your discontinuous variation can be the gender, right? If you're either a male or female, that's all. There's no in between, right? The eye color is one good example, as well as the blood group. But for your continuous variation, your height, your skin color, yes, skin color is a very good example because over time it gets affected by environmental conditions as well. So if you are exposed to light for too long, you start to become tanner, right? So this is a very good example of what a continuous variation will look like. Yep, and with that we have come to the end of this video. And stay tuned for the last video, which is on mutation. Goodbye.